Hello, everybody. Welcome to Unstructured Data. We organize these meetups once a month to bring people together for discussions to collaboratively learn from each other about unstructured data and generative AI. This event tonight is sponsored by Zilliz. We're the maintainers of the open source vector database Milvus. Give us a star. And we're also sponsored by Airbyte tonight. Airbyte, open source standard for data movement from any source to any destination. So Milvus is open source vector database designed for storing, indexing, and searching millions of vectors. We have 4 SDKs, Python, Java, Node, and Ruby, over 24,000 GitHub stars, 8 million pip installs, 50 projects with over 1 billion vectors in production, we're 113 million Series B, more than 5,000 enterprise adopters. Our Zilliz cloud is enterprise ready. And some of our customers include Roblox, AT&T, Bosch, IBM, Intel, NVIDIA, Trend Micro, eBay, PayPal, IKEA, Walmart, Shell. All right, so that was my spiel. So now let's get on with our talks. We've got 3 great talks tonight. They're each going to be about 25 minutes, and save your questions to the end. We'll try to keep 10 minutes at the end for your questions. So our first speaker is James Luan. He is our VP of Engineering at Zilliz. He has extensive experience as a database engineer at Oracle, Hedvig, and Alibaba Cloud. He developed the HBase, Alibaba Cloud's open source database. He's a member of the Technical Advisory Committee of Linux Foundation AI and Data. He has a Master in Computer Engineering from Cornell University. And he's going to speak to us about Vector Database Performance Optimized 101. Welcome, James. Oh. Yeah, so you should.
This one? So today I'm going to talk about how to improve the performance and put your vector search into production. Yeah. So I'm James, VP Engineer at Zilliz. I'm currently Milvus maintainer. If you guys by chance know Milvus, I'm actually very active in the community. So I'm also like an open source developer for multiple projects. So welcome. Yeah. So I know like a lot of you guys have been using vector search for a while. Some people said that vector search is actually very easy, especially if you have a large amount of your unstructured data, you directly throw it into an embedding model. After you get all those embeddings, you throw it into your VectorDB, and you get all you need, right? So I know a lot of competitors, they actually put a lot of words like easy to use and simple into their web page. Those seems to be finishing 10 lines of code. No need to learn anything about machine learning. No need to learn anything about AI. No ETL necessary. No node tuning. Yeah, it could be as easy as a NumPy, right? So this is a short demo I read this morning. Use 10 lines of Python code, so you can have very easy version of your vector search. And it's 100% accurate, right? Because it's a key-in algorithm. Yeah, but the fact is, you have large amount of data. If you go through what happens, have 1,000 vectors, then your performance is going to be good. Have 10,000 might be good. Have more than 1 million, 10 million, definitely that won't be working on production environment. Yeah. So that's why we have long chain. That's why we have Airbyte, and that's why we have Milvus. Right? If you want to build a real-world production app, then you have to consider about everything. Oops. right? It's like search items on the Amazon. First of all, you thought it's going to be easy. Then you keep typing, trying to find something new. You get crazy. You want to have search qualities, scalabilities, multi-tenancy, cost, security, everything before you ship it into real world production, right? And that's what you get, right? That will be a super complicated rack systems. Yeah. So today, we're just going to talk. What if you need to learn if you want to put VectorDB into production, right? Currently, there are like 3 different advice. First thing is design your schema. Second thing is think about how to scale. Third thing is how to pick your right index and tune the performance. First thing, design your schema. I know a lot of you guys have experience in using some of the VectorDBs. They are kind of like dynamic schema, right? Using JSON, it seems to be very flexible. Put everything into a JSON and it magically works, right? No need to do alignment, no need to do ETL. Yeah. On the other side, I know that if you are PG vector users, you might be very familiar with fixed schemas, right? It's going to be performant. It's also going to save your main memory because it does some compact, like storage format, right? Yeah. So if you're trying to build AI applications, I would recommend to use hybrid schemas. So which means you have most of the critical path using your fixed schema, and so you have this dynamic schema to make sure that your app is going to be flexible, because under some of the use cases, you're going to have some flexibilities, right? You have a product name, but some in the other like entities, that might be a critical one, right? Then you may have some product IDs. So if you want to put all those things into your line, then you should use dynamic schemas. Second thing is to think about primary keys and partition keys. That is also going to be very critical. If you are very familiar with relational database, then you know what I'm saying, right? So pick up your what key is going to be indexed on, pick up what key is going to be ordered on, right? So in Milvus, we just split every row into multiple parts. One for sure is going to be your payload. You have fixed field, you have dynamic field. One definitely for sure is going to have a vector field, because VectorDB must have a vector into it. And you also have some system field, which you have your timestamp, your row IDs. It's pretty similar to what a database should have. And the most important part will be primary key and partition key. So for primary key, it's going to be unique. You're going to retrieve it very frequently. Most likely, it's going to be a chunk ID or an image ID. And primary key also can be auto-generated if you don't know what does it means, right? Yeah, and primary key also help you to scale, especially have you like billion level status. You definitely don't want to put into one shard. We'll talk about what is shard, but generally speaking, you just split all your data to different shards based on hash, right? A partition key is going to be another very important feature, especially when you want to build some rack systems to those consumer applications. You have million level DAUs. Each of the users definitely want them to share their data. Then partition key helps you to do multi-tenant. With this feature, like it's usually going to be a user ID or tenant ID. So with this partition key, you can just easily scale all the databases to support more than like million level tenants. Third thing is going to be pick your embedding tabs. So originally we support dense embeddings, and it's going to be the most common one, OpenAI embeddings. If you're familiar with open source BGE, Cohere, it's going to be business offerings. So for index, you're going to have FES and HSW for open source. Yeah, but now we have more choice, right? We have sparse embeddings. It's going to be super efficient for out of domain, and it's going to be just released for Milvus 2.4. We have Split as a model. We have BGM3. So those embedding models help you to do hybrid search, so you can search across both dense and sparse embeddings. We also support multiple different index for sparse embeddings. And this, I think this morning, Cohere just released another model where their model can just generate binary embeddings. So now we also support binary embeddings. So those are just 0 1s. They save you a lot of memory. Yeah, it also under some of the use cases, especially for protein search, They also kind of like have the special model. For example, Meta ESM, they also generate binary embeddings. Okay, so summarize all those together. So how will I do if I want to build a reg application? Yeah, so that is a very basic simples. First of all, you have a chunk ID. Chunk ID will be work as your primary key, so it's going to be unique. You have user ID if it's multi-tenancy use cases. You have document ID. Under some kind of use cases, you don't want to search for the top 10 chunks, other than you just want to have the top 10 document. Then you can just using the grouping search features offered by Milvus. So it's going to be grouped by the document ID and give you the top 10 document. You have the chunk data that's going to be super useful to ranking all the data. You have a lot of parameters. Those are just stored in a JSON file, so you can just add them like a document address, document source, those kind of stuffs. You have different kind of embeddings, sparse, dense, and you can like do have research among them. Okay. Second thing to do is think about how to scale. So generally speaking, unlike the traditional relational databases, if you're using PT vector, they store everything into a large, gigantic index. So you basically have two problems. First of all, is index speed is going to be super slow. Second thing is that if you have a lot of update, then the index the quality will become bad and the search quality will be reduced. So what we do is we have multiple segments. So we split all the data into segments. And when you do delayed update, once the segment becomes unstable, we'll try to compact and make sure that your search quality keeps at the same style, right? And with this segment, it's also very good for load balance. So even if you have multiple query nodes, we're just going to split evenly on all the query nodes, make sure that distributed works well, right? And on top of each segment, we actually have partitions. If you're trying to build something for your complaint, you can have department ID as your partition. So when search happens, they can only see their own partitions. You can have date when you build this agent. So you only want to see the latest 1 day or 2 day information. You can have goods type if you try to build something like e-commerce search. Yeah, and on top of it, there'll be shard. Shard will be more like just help you to scale your data. You have 1 million data, just use one shard. Have 100 million data, one shard could be probably good enough. If you have more than that, maybe just split data into shards. Yeah, so here's a best practice. So we can definitely hold 10 billion data into one collection. And so far as I know, we have largest deployments is around 20 billion per collection. So you definitely have to split into shards. Each shard is usually going to be 500 million. So if you're trying to build multi-tenant apps, you have less than 10K tenants, simply just to do it by collections, so you have better control. But if you're trying to build some applications for million-level users, think of using like partition key as a feature. So you have unlimited number of tenants, because when we do partition key, it's like hybrid approach for both logical and physical isolation. So we first split all the data into physical segments, then we do filters on top of it, so you can have unlimited tenants. And what about query per second, right? We actually very distributed, so we don't really need to worry about it. Just add more query nodes, helps to increase the performance. If you have very small data set, maybe it's not good enough to scale, then you can add memory replicas. So hold like 2 or 3 memory replicas, and doubles your QPS. And last thing very important is how do you going to pick your index, right? We actually offer very flexible index selection policy. On the top, we have GPU index. We actually have one session on GTC tomorrow, talks about how we perform high efficiency search with GPU. It's going to be a collaboration between us and the NVIDIA team. So if you're interested for the high performance use cases, you can take a look at it. And in the middle, there will be memory. You have 1,000 level QPS. You can scale to terabytes of storage. You get 10 milliseconds latency. Yeah, and on the lower level, you get disk I thought we are the only open source solution that support DCN. Yeah, it's going to be support tens of terabytes of storage. You get reasonable latency, 100 milliseconds. Yeah, and at the lowest level, you will get swap. So it's going to be a newer type. We try to swap data between S3, all the object storage, and the Milvus itself. So data don't need to host fully in the vector database. So which means you're gonna have like 10 times cost reduction. And latency is kind of like based on what the frequency will be. Ideally, it's going to be 100 milliseconds, but for the code data, it might be a seconds, but it's still good enough for some of the offline use cases as well as the reg. Okay. So then, once you pick what kind of index you're going to use, how to evaluate it, right? Those are things you need to consider about: the build time, accuracy, performance, resource usage. And here's a general guide of what happens, right? If you don't use an index, you get 20 query per second. You don't really need to build it. You have every flight, the index building is going to be faster. QPS definitely 10 times. Using scans, it's going to be another 10 times. But but if you have HSW, build time is going to be much higher. But QPS is definitely like higher than scan, right? So pick your right index type, tune the index parameters, benchmark on your use cases, tune the search parameters. And if you don't know how to tune that, simply use our VectorDB bench. It's actually, we open source our internal benchmark, help you to evaluate. We also, it's not only for Milvus, it also have all of the like mainstream VectorDB. So you can always do your own experiment and tune the performance. Yeah. And here is a quick cheat sheet about all the index performance from GPU index Kagura. We're going to release today. We have HW. I guess you guys are very familiar. We have Google Scan. We have FF series with quantization and Dscan. So if you're trying to like make sure you have best performance and cost efficiency, you should just check the table, find whatever your application is located. Yeah. That's pretty much about my talk. Yeah, thanks.
Thank you. Let's see if we have any questions. So I have a quick question. I heard a user this morning asking, they were trying to figure out how to design. They said for like looking for movie reviews. So they have not only the movie reviews themselves, which are long texts and many texts, they also have the movie description. So what he was asking, should I have both texts? Should I just merge them together? Should I have separate vector columns for search? What do you recommend for that?
Yeah, good one. Yeah. So before 2.4, so Milvus only have one vector field for each of your data. So under some of the use cases, you may have multiple fields, right? You have comments, you have titles, you have abstract. Then I would recommend to put everything into one row. So for each of the row, you can have their own embeddings, and you do search to find maybe top key result on each of the embeddings. That is what we call that a hybrid search. After you have researched all the field, then what you can do is you can just do a re-ranking model. So the easiest way to do a re-ranking is just using a weighted ranker. So you just give them some weight, right? Just do some average on top of them. And you can also based on ranking. So we have a ranker named RF. So it's kind of like based on the ranking to trying to convert all those fields into one ranking. Yeah, and you can also use some models. For example, you can use Cohere re-ranker. For open source, you can always use BG re-ranker. So you just throw all the document into it, and they will give you the most similar result.
2 vector columns. All right. Okay, I see a question back here.
So thanks for presentation. Can you please suggest or advise, is there any place I can try kind of sandbox different indexes for my data set and in order to figure out which one works for me the best?
Yeah, good question. So for Milvus itself, it's actually going to be very flexible. So the way we are trying to build VectorDB is not just to create your index. It's actually we have collections and index on top of it. So you can just insert all your data into one collection and create index on top of it, doing all of your search. If it doesn't really work, you just drop the index, create another index. That's the easiest way to do that. And we have this benchmark thing. So it's just going to be some parameters change. So yeah.
Okay.
Thank you very much for your presentation. Regarding embedding types, can you open the slides?
It's fine. Right?
Yes, exactly. Pick embedding types. Okay, how should I pick one of them? Because you put like different distances and still I don't get the embeddings, and there are many vectors coming out, I think, based on each embedding.
Interesting question. So first of all, it's kind of like based on your use cases. First of all, I will try to explain the difference between sparse and dense. So dense is usually what we use as a traditional way. So I know a lot of guys just using open embeddings. They have the good part for dense embeddings, they have long context. So we have all the semantic information. But the bad part for it is that they lost some of the details, right? For example, I saw what is the movie you see last night. They may give me the result of what is the movie I say last year, because they are kind of like very similar in semantic field, right? So what if I exactly want the last day or yesterday, right? There are two ways. One is to do filtering. So I have all the tags into my schemas. I know what the date it happens. I do a filtering. The other way is using sparse embeddings. So generally speaking, sparse embeddings are just, if you see that they have around 30K different dimensions. Each of the dimensions is just one token. If you guys are very familiar with BERT, this is exactly the same dimension as BERT does. So each of the dimension is actually one token. So yesterday might be one token or two tokens. So and the number on top of it is actually how relevant this token with this with these articles. So sparse embedding gave you a lot of details. When you merge them together, you do heavy search, you have both details and context. And for binary embeddings, first of all, it's going to be usable for some of the special use cases. For example, biology. Yeah, and secondly, a lot of model companies, they're trying to save your memory, right? One thing to do is just like dimension reduction, just like OpenAI did. They have this MRS thing. So for very long vectors, you can just cut off and use smaller. And the other thing you can do is just doing quantizations. So Cohere, they just released a new model here. They can have int8 quantization. They can also have binary quantizations. So they just convert those flow 32 into 1 bit. You still have all the semantics. It have reductions in recall, but it definitely help you to save memory. Yeah.
Do you know how to make perplexities RAG?
Yeah.
The exact algorithm, because I've tried to mimic it, and is it the way they clean and normalize their data, or is it just the structure? Or I'm not sure. Are they using vector, or are they using? Everyone use Python with JSON, of course, but how do you set that up when you're doing perplexity? If you want to match perplexities RAG model.
Yeah, I thought it's going to be very complicated. So, but I thought currently we are like more focused on like how we can do it scale, right? Yeah, but I think to match their models, you definitely have to do a lot of like data cleans. You have to use a lot of trick on the RAGs. Yeah, we can definitely like talk about offline. Yeah, they have these hide things, right? They generate questions. They also have a lot of tricks. So. If that graph might be a little bit small, I just want to see how complex it is. But yeah, to put into real production, you definitely need to do all those. Yeah.
So I heard a question during the pizza time. Somebody was asking me, how does that VDB bench work? We provide data sets. What kind of database could you bring for evaluation, and what do you get out?
Yeah. So first of all, VDBench is open source by us. So I wouldn't see it's a third party evaluation. The way we do that is, first of all, we want to keep everything open. It's actually our internal tool. So we use it to measure the difference between us and all the competitors. Yeah. So one major difference that we introduce a lot of new data set. For if you go back to AM benchmark, they have this SIF data set, they have glove data set that is back to 10 years ago. Now what users cares about should be OpenAI embeddings, Cohere embeddings, right? Voyage embeddings. So we introduce those new data set. Second thing is we actually have more use cases. We have filterings, we have hybrid search, we're going to add sparse embeddings. So those are the use cases you want to put into production. And that's a major difference. It is actually deployable in a Docker, so it should be just bring up in one command. So it helps you to evaluate very fast. We also have multiple connectors. So if you're trying to evaluate your VectorDBs, no matter if it is Milvus or not, you can just rewrite these connectors. Yeah, we have some like common connectors for all the options. Yeah, but feel free to add your choice. It's open source, so we are open to have all the results. Yeah.
We also have a Twitch stream, and we have 2 questions coming in from Twitch. I'm curious if you published any of your thinking about keeping different text sources in the same vector database. Let's say I've got Airflow logs and JSON documents. Thoughts on that? 2 databases or 1?
Good question. So I think kind of like based on your choice. So what we're trying to do is trying to put all those things into VectorDB because we thought it's going to be more powerful if you have all the information together rather than a data silo. It definitely has some cost. So first of all the VectorDBs, most of the time they just put all the scattered data into memory. That will cost you a lot of memories. So what we do is we're trying to have this new engine trying to put everything on the disk, so it's going to be better, but it's still like if you compare to the performance, I think MongoDB will be one of your choice. Redis might be one of your choice. Yes, under some of the use cases, especially if you have large chunks, I still recommend it to put it outside VectorDB. But for all the meta informations, definitely yes, put it into VectorDB.
Okay, we got one more question. Second related question is about the schemas. Can you have multiple schemas in a single database, or should I think of a schema as tied to a table?
Yeah, so we have multi-collections into one database. So each collection has one schema. So it's just like what you use in MySQL or PT, right? So you have table for each table has a schema. So yeah, I just want to say that for some of the open source vector databases, they keep telling you that schema is not important. It's going to be super easy. Just use it. It's going to be out of box. But the thing is, you have to think about it, especially when your applications grows, right? You have to think about this. Yeah.
Hey, well, let's thank our speaker again. Thanks, James.
Thanks.
So I should have asked this when in the introduction. How many of you are using Milvus? I know a few people. Okay, so of the people who are using Milvus, are any of you willing to give a demo in front of everybody at the end? All right, never mind. So if you are, be ready next time, because we'll give you time at the end to do a community demo, like a 5-minute demo. And then also, if anybody has job openings, you can announce those at the end too, because we have job seekers here. All right, let me get my. All right, so our next speaker is software engineer, machine learning at LangChain. Lance Martin was one of their first employees at LangChain, and I don't have my speaker notes in front of me, but he also has earned his PhD in machine learning at Stanford. Welcome, Lance.
That's good enough. Thank you. Is this supposed to work? I'll just speak aloud. It's great to be here. My talk is unprovocatively titled, "Is RAG Really Dead?" So hopefully we'll get to answering that here.
Hey, sorry to interrupt. If you want
Yeah.
to step up to the podium mic there, that one's.
Oh, this is the functional mic.
Yes.
I got
Thank
you. Okay, this one is not working. There we go. So everyone probably knows that context windows are getting larger. So on the X here, we can see, different pre-training tokens. So from like 1.5 trillion, and for small models like Phi 2, up to some big number we don't know for Claude GPT-4. But the more interesting thing is here on the Y-axis, you can see context windows were pretty small even a year ago, between like 8K, 4K tokens. We saw 32K kind of earlier this year. Open source models are kind of now around 32K. We saw Claude earlier this year opened with like 200K tokens, and now we're seeing models up to 1 million tokens. So we know context windows are getting much larger. So we've seen a lot of this on Twitter, people saying, well, does this mean RAG is dead? If you can feed 1 million tokens is some number of 1,000 pages, right? So that's a huge amount of context. Do you need retrievers anymore? Can you just stuff information in directly to context? So first, maybe just as like a framing, like what is RAG? So RAG is reasoning and retrieval over chunks of information you retrieve from a system. So the last talk we heard was really nice, talked a lot about the details there, and that's kind of in this blue box here. So you've indexing, right? You have some set of documents, you index them, you can retrieve them easily using similarity search or something like that. Retrieve relevant docs, put them in the context window of an LLM, ask an LLM to produce a response grounded in the retrieved docs. That's RAG, right? So a reasonable question to ask is, can a long context LLM do this? So there's been some analyses, needle in a haystack, that have come out, and I recently kind of took a stab at this myself. So the question is, if I feed in a few random facts into the context window of an LLM, can the LLM retrieve them all, just like RAG would, right? So here is the setup. You can't really read it, but I'll just tell you. Basically, I'm injecting pizza ingredients into a set of Paul Graham essays, okay? So it's like 3 secret pizza ingredients. It's figs, prosciutto, and goat cheese, okay? And what I do is I ask the LLM, so GPT-4, what are the ingredients need to build the perfect pizza? And I do this as I change the context window. So I try first small, 1,000 tokens, and I ramp that all the way up to GPT-4 was 128,000. So I stuff these ingredients in there as needles, and I say, can it actually find them? Like a RAG system in principle could. But can the long context LLMs do that? So here's kind of what I found. It's a pretty interesting result, and I'll just kind of walk through it. So on the left here, what I'm comparing is green's retrieval, red is like reasoning on top of the needles. And the reasoning challenge is retrieve the needles and tell me the first 3 letters, or the first letter of each one. So here's the point. As I increase the number of needles, that's like on the X here, so I go from 1 to 3 to 10 needles, and this is a fraction of correct. On the Y, it gets worse. So this is GPT-4. It gets worse as you put more facts in, which is kind of what you would expect. And this is all at 120,000 tokens. So basically the intuition here is more needles, worse performance. With a RAG system, you can pretty easily retrieve 3 facts from a corpus. If you just stuff 3 facts into a long context LLM and say, find them, it may or may not work. And on the right here, I kind of explain why a little bit more. So what I show on the X is different context lengths, so 1,000 all the way up to 120,000 tokens. And on the Y, I'm showing you all the different needles in the document. So the top is like the start of the doc, and then I go to the bottom, okay? So that's like the order of the needles, different context lengths. Green means I found it, red means I didn't. The key trend is this. You see the red all at the top. Basically, it forgets facts towards the beginning of the document. It's kind of like you. If you read a book, right, you remember the stuff you read last more easily than like something at the start. If I ask you a question from the first chapter of the book, you might not remember. Apparently, it happens with GPT-4 as well. So this is really a warning sign that you cannot assure yourself or have guaranteed you get retrieval if you just count on retrieving facts from the corpus of 120,000 tokens or 1 million tokens. These retrieval patterns are non-obvious. So I put this out on Twitter and got a lot of responses, and a really interesting one came from a paper from some OpenAI authors that was cited. And he mentioned to me, this may be the way the LLMs are trained. So when you think about the next token prediction challenge, when you train these models, the most informative tokens for predicting the next token are typically near or close to it. So you get this thing called recency bias. So LLMs, the way they're trained, they tend to look for nearby tokens to answer questions. And that, if you kind of go back, that kind of explains like, it's biasing towards the latter half of the document when it's answering your question, and it can forget earlier things, potentially due to this recency bias phenomenon. In any case, no question, this will get better. People are working on it. And this is kind of my little joke. Frank Zappa had the line, jazz isn't dead, it just smells funny. I think RAG isn't dead, but it's changing, it's different. I think this effect will get better, but definitely RAG will change. So one way I think it'll change is RAG today is focused on like precise retrieval of document chunks. So this is kind of a typical flow. You take documents, you split them up into chunks. Setting your chunk size is like highly kind of like idiosyncratic art. 1,000 tokens, 500 tokens, you can get different answers depending on where you look. You index them like we just saw. You retrieve them based on relevance. You might filter, re-rank, compress, and then do your generations. That's like today, right? The whole idea is very precise retrieval of just relevant doc chunks. And I think, you know, a way to think about this is you move to a world of like long context, you're kind of like balancing two things, right? So on the left is kind of like maybe today, like really, really nervous. I just want the most relevant chunk. I'm trying to like build these really complex systems. I have re-ranking. I have like post filtering. I'm like tuning my chunk size just to get that right exact fact. I'm fine tuning my embeddings. So that's like kind of maybe on the left. Like I'm really, really worried I need the exact right chunk. And then the far right is kind of the Twitter take that's like spicy now. RAG is dead. Stuff it all in. You don't need RAG at all. And I think that kind of Pareto optimal is probably somewhere in the middle of like balancing, you know, high system complexity on the left with you're wasting a lot of tokens and latency if you're just stuffing everything in. Right now, if you take GPT-4, you put 100,000 tokens in, it's about $1. I spent a lot of money doing this for some of these RAG things, and I don't want to know what my bill was. And yeah, Harrison, my CEO, I also don't want him to know. But so the point is, it's actually very expensive. If you were to just like stuff 100,000 tokens, all your docs in, and just do like retrieval using them, you're going to waste a lot of money. That's really not production ready. So again, I think thinking about something here in the middle is kind of like a Pareto optimal way to do it. And one kind of idea, I put this out on Twitter, I think this is kind of a sane take, is like maybe just kind of think about inclusion at the document level rather than the document chunk level. And I'll kind of walk through like kind of some ways I think that might work. So I think that there's a lot of approaches for query analysis. I kind of have like a whole RAG series that talks a lot about query analysis. I think in the world of long context LLMs, this stuff kind of still all exists and is still important. Like the challenge here is you're trying to take questions and route them either to the right database or to the right document. This probably doesn't change too much with long context LLMs, right? So, you know, query analysis is really all about, it's kind of hard to see, but basically restructuring questions to improve retrieval. I think that'll still be relevant. Routing, taking a question, routing it to the right database or to find the right document, that's still relevant. Query construction, text to SQL, text to Cypher for GraphDBs, that's all still relevant. So I think this stuff doesn't change too much, even with long context LLMs. I think what's interesting to think about is tricks for indexing that take advantage of long context. So this is one I really like. I've done a lot on this one. It's using representations to simplify retrieval. And I'll tell you exactly what I mean by that. There's a cool paper called DenseX Retriever. And what it did was take a document, produce a summary of the document, index the summary, and retrieve based on the summary. So basically think about it like this. You take a document, have an LLM summarize it, embed that summary. You store the summary in a vector store like we just saw, but you link it to the full document, right? Imagine your LLM has a, 100,000 context window. You can fast the whole document in, no problem, right? You don't have to chunk it, but you just want to make sure you get the right document. So you use what was called in the paper proposition indexing, what I like to think of it just like summarization indexing. Index a summary just so you get the whole document back and pass that whole document into the LLM. So it's a nice trick. I've used this a whole bunch. It works well for images too. You can summarize images and then do like text-based lookup of images and then pass images through. It works really well for tables. Really nice trick. I've used it a ton. I'll share these slides and I have some good examples. So I think this is one trick. Like basically pass full documents to the LLM for the final answer generation, but use tricks to basically summarize them for indexing to make them really easy to recover. Don't worry about chunking. So I think that's like kind of trick one. This is another one I put out, and like a lot of people seem to like it. So it's this paper called Raptor. It's kind of a cool idea of building like document summarization trees. And the big idea is this: imagine you have a whole set of documents, and like sometimes a question needs to reference like multiple documents. So all you do is you take your documents, you cluster them, and you produce a summary of the cluster. So these cluster summaries basically capture information across different documents, and you keep doing that to build like this kind of tree where you can have higher level information captured in these clusters, and then you index all of them. So like if you have a question that needs information from like 2 or 3 different documents, these cluster summaries can capture that. Again, nice trick, can work across documents, pretty cool. So again, I have a video there. It's a really nice paper as well. So it's another trick to think about working with documents rather than individual chunks. Long context embeddings I think are really cool. 32,000 tokens is now enabled with Together AI has a really neat one. I encourage you to look at these. Then you can kind of index full documents and use something like Raptor like we just talked about. And the last one is something that I've been working on quite a bit recently. It's really neat, I think. Moving away from RAG as like a single shot process to RAG as like kind of a feedback loop is really promising direction. So typically today, if you think about it, you do retrieval, you get your docs, you do your generation, and you're done. But why can't you kind of cycle back? Why can't you grade your documents? Why can't you grade your answer? If you don't like either one, try again. I think we're going to move more to this agentic RAG style flow. And I actually use LangGraph to implement this. It's a cool paper called Self-RAG. And the idea is, just like we saw, you take your question, do retrieval, but then you actually grade the retrieved documents. Are they relevant or not? If they're not relevant, you rewrite your question, you try again. Then you go to your generation, you generate your answer. Are there hallucinations? If yes, try again. Does it answer your question? If no, try again. So anyway, I think another idea in RAG is like, and this is relevant regardless of context length. It's like kind of thinking beyond just retrieval and generation to like building like what I call like more like workflows around the RAG pipeline that give you some self-reflection. I think is going to be a really interesting trend going forward. And then we actually do this with LangGraph. You can use like an agent to do this as well. I find LangGraph to be a little bit better because that's a whole other discussion, but it's just basically very predictable in its behavior. So that's another really nice idea. So, overall picture, like, is RAG dead? No, I don't think it's dead. I think it changes. I think we can kind of move from thinking about individual doc chunks, very precise chunk retrieval, more to thinking about like, I think everything, query construction, query analysis, routing probably doesn't change much. I think it's all still really relevant. Indexing tricks for full documents are going to be really interesting. I just talked about 2 of them. There's a lot more. And I think moving from just like kind of single shot RAG to like kind of reasoning generation flows with feedback is another trend that's kind of independent of context size. That'll be really interesting to think about going forward. So those are a few ideas, but I think that's all I had. Yeah, happy to take any questions. And I'll make sure these slides are all shared. So there's a bunch of links in here. So that's about it. Thank you.
Thank you, Lance. So let's see if we have questions. Okay, well, you guys are already called on you. I'm going to pass it.
Thank you.
What's that? Yeah.
Thank you for the presentation.
Okay, there we go.
Okay, thank you. So I think you mentioned an idea that says the reason why there's a recency bias is because of the next token generation task, which is widely adopted in the generation part, aka the decoder. So I was wondering, like, if people try to change another type of loss, which focuses more on the long-term like memory in this part of the generation task, is that going to partially solve the recency bias? Let's say that we focus more on the tokens that are more conditioned on, the tokens which are far away from this particular token, so that in this way, is it possible that the model is gonna be tilted towards having a longer term of memory, which in turn partially solves this, recency bias and makes, longer text, context window viable for, generation tasks?
Yeah, exactly. The question is, if this recency bias is due to the loss, which is basically next to a prediction, or the challenge, can you address it with different loss functions or other tricks? And I'm sure this is something that OpenAI is looking into in depth. Yes, I'm sure that's true. There's also some interesting work I kind of talk about on monarch mixers. There's kind of different architectures beyond transformers, which I'm sure people are thinking about quite a bit. Like, this is something that the model makers are without question digging into. They were actually really involved in some of the earlier work so Greg and I did this analysis together. Greg reported this same result actually back in November, and he's talked to OpenAI a lot about it. I'm sure this is something they're absolutely trying to fix. I don't know what tricks they're going to use, but like, you're on the right track. It's going to be loss function, maybe different architecture tricks, but it's absolutely something I'm sure they're all over. But yeah, good question. Yeah, I'm sure there's things they're trying to do there.
Can I ask a follow-up question? So for this part, are these, needles distributed evenly, or?
Yeah, they are. So basically, the way this is structured is, and it's actually all open source, by the way, so you can play with this yourself. And basically, you set the position of the first needle, and the others are equally spaced beyond it. So in this case, I set it like 5% document, and then boom, the rest are just set automatically. Yeah.
Thank you so much.
Yeah. I can hear you. Yeah.
So one thing I thought was interesting with the summary, with using summaries of knowledge.
Yeah.
It reminded me a lot in psychology education, where they talk about chunking in terms of learning, where you're actually trying to combine things together eventually into higher and higher sequence of abstractions. You see the way it's going to be stored. You see like multiple summaries of multiple chunks of knowledge.
Yeah, so that's a great point. Actually, the paper is focused specifically on, like, this tree is an abstraction tree. You're exactly right. So like, you're taking your documents and you're embedding them and you're clustering them. So you're like documents, you're kind of clustering together, and then you're summarizing that cluster. Like you're saying, you're building a more abstract representation of that cluster that's consolidating information from the various documents, and you're doing that recursively until you have one cluster left. So you're absolutely right. You can think of this as an abstraction kind of hierarchy, going from like the least abstract individual documents to very high level abstraction that encompasses everything. So it's exactly right.
Yeah, I guess the follow-up I have to that is how are you testing that's actually getting more accurate on top of those abstractions?
Well, okay, so here's an interesting point. What you do is you actually index everything. So you index the raw docs, at least what they report in the paper. They index the raw documents and all the summaries together. So basically, if you have a question that requires information that encompasses a few things, based on semantic similarity, you're likely to basically extract that like higher level doc, like that higher level doc summary out. So that's a very important point. They just flat index everything together. And they actually, I encourage you to read the paper. It's called Raptor. It's very interesting. And they report on this. They basically say, just indexing or embedding everything is the best result. So you can retrieve these like higher levels, like chunks, if your question warrants it. Yeah. Yeah.
Hey, on Self-Rank, where you're giving it feedback based on the quality of its response, is that a human in the loop determining the quality, or is that some preset criteria?
No, that's a good point. So I actually is using LLM as a grader, which is actually pretty commonly done. OpenAI has some notebooks on this, but you actually use an LLM as a grader to like grade the relevance of the documents, grade hallucinations, grade answers, and it actually works really well. LLMs are really good at like kind of comparative analysis between two chunks. So like, if you say, here's my question, here's a retrieved doc, are they related? I can often get that right. So LLM graders throughout this, no human intervention. Yeah, it's a good question. It's slower than single shot, but it's not crazy. It's constrained by the latency of your LLM. So if you want to use like a faster, I actually encourage using like a higher order LLM for grading. There's a lot of questions. If this is in production, I get it. Latency really matters. In that case, you're right. You'd have to bias towards a faster LLM, which may or may not be quite as accurate. It's a good question. Yeah.
What if it gets in circles?
Yeah, that's a good point. So I set a recursion limit. Yeah, it's exactly right. So with these loops, so first of all, LangGraph actually has, you can set a higher level graph recursion limit, but actually just in terms of token use, I set my own as like a parameter. So I just say, try 3 times, otherwise just like exit. So like return the best response after 3 tries regardless.
Just to also clarify, the hierarchy.
Yeah.
Doesn't, it falls off or so you have to do it together or fall off.
Yeah, maybe I should clarify this even more. So here's what's going on. You have a set of documents, you embed them, you cluster them. Okay, so that's what's shown those clusters. Every cluster you summarize. So you have these summaries, right? And you keep doing that until you have only one cluster left. So then what you have is your original documents and a whole bunch of cluster summaries, right? You just treat those cluster summaries as documents and you just embed all of them and use them all for retrieval together as like one big pool. Raw docs plus these like higher level cluster like summaries, and that's it. They report that works the best. Yep.
I have a quick question from Twitch. You have extensive experience with RAG solutions. Obviously, how commonly known are these techniques in the engineering community outside of the AI community?
Yeah, I mean, we've kind of have this video series called RAG from Scratch that I did that kind of walks through this from the beginning, and we're working with Free Code Camp to put it on there, so like that'll help distribute it to the broader software community. I think it's getting out there. But yeah, I think there's a lot of opportunity to distribute these ideas further for sure.
And then the second part is you didn't mention graph of thought techniques. Also, maybe unrelated, how much are you using knowledge graphs in your implementation?
Yeah, that's a good question, actually. So I briefly mentioned knowledge graph RAG somewhere. So I mentioned. I kind of show knowledge graphs as one option for RAG, but I didn't actually really talk about using knowledge graphs for RAG. I think it's interesting, but I haven't really played with that myself. This is actually something called LangGraph. That's a good point. This is not a knowledge graph. This is a workflow orchestrator. It's like an agent type thing. It uses a graph as like a workflow. It's not like a graph RAG database. It's not a graph database. So
Great.
yeah, very good point. Oh yeah.
Back to the 5-minute hierarchy.
Oh yeah.
So that's when you go from the database into the document, right? To like zoom in. What if you do like the opposite way? When you start with a keyword search, you find like a specific term that you are looking for, and then you expand your term until it answers the question, like a agentic chapter. I'm looking for a project to work on. So
that is kind of interesting. So what you're saying is, okay, that maybe relates a little bit more to kind of this. I wish I had it here. I have a pretty cool demo called Corrective RAG. Find me after, I'll send it to you. So basically it's using a graph like this, but here's what we do. So you do retrieval based on your vector store. You try to answer the question. You grade the documents retrieved. If they don't answer the question, you kick off a web search. And then you search for the information outside your vector store because the implication is it's not present in your VectorDB, kind of like what you're saying. So you're saying you start with like a narrow search. If you don't find it, you expand your search. That's exactly what we do with this thing called Corrective RAG, CRAG. We have a video on it that I did a while back. But yeah, it's a good idea, and more ideas like that would make a lot of sense.
So a lot of these ideas seem to be converging on symbolic AI, semantic web. First, is that the case? And second, do you see the equilibrium being we just use actual symbolic AI, semantic web principles in combination with LLMs and this type of AI, or is just LLMs all you need?
I don't know what symbolic AI is. What is that?
So it's basically knowledge representations based on their actual abstract meaning, as opposed to just like an LLM which treats just tokens sort of randomly, right? There's no intelligence in there.
What do you think is most related to that, though, in these?
So the knowledge graphs or these clustering of information.
Oh, okay.
Knowledge tree. So
yeah,
almost like a knowledge graph.
Yeah. I realize I can pick this up. That would have been convenient this whole time. Maybe. Yeah, I mean, it's a cool paper. We could talk about that afterwards. I haven't thought about it in too much depth other than the intuition from the paper that I capture is basically this. A lot of questions need information consolidated across a few different documents, and these summaries do that. So it's kind of like I think what we were talking about over here, you build these higher level abstract summaries, which are good for questions that are like higher level. So some questions regard only one paper, then you can retrieve that paper and answer the question. Some questions require 3 papers, and these summaries are meant to kind of capture those higher level questions. That's the main intuition I draw from it. But I'm not sure about the semantic AI stuff, but maybe, yeah. Yep.
One quick follow-up about self-reg.
Oh, yeah.
Do you have any practical experience like compare the self-reg performance versus the reinforcement learning with human feedback? Like for which scenario you prefer self-reg? I know it's definitely computational efficient, but what other advantage you may have compared to RLHF? Yeah.
Well, yeah, RLHF I think is, yeah, that's like way outside the scope of I think what we're talking about here. RLHF is kind of like an alignment procedure for LLMs, whereas this is just kind of really simply a process to grade RAG and retrieval and generations. So I've actually found this to be extremely effective, and that corrective RAG, I think I mentioned to him, is also really, really nice trick to improve RAG performance. Latency, like this guy mentioned, is definitely a concern, but I found it to be not that terrible for many cases, especially if you set, like we were talking about here, a recursion limit. It's a really nice trick. And in particular, the trick where you kind of kick out and do a web search, the corrective RAG thing, I have a similar LangGraph thing for that. That really works well. So if there's something that, if the user asks something outside your VectorDB, you don't just fail. You can actually like grade the retrievals. And this happens a lot, right? Like you ask something kind of out of sample, your VectorDB returns some weird chunks. It answers a question completely irrelevant. If you had a grader in the loop, the grader would say, ooh, these retrievals are totally irrelevant. And they would kick off a web search. It would gracefully kind of return a reasonable solution rather than returning total garbage to the user. So it's a nice trick.
All right, let's thank our speaker again. So I don't know if you'll stick around afterwards, Lance, if there's more questions.
Yeah, I think
Okay,
so.
great.
Yeah.
All right, so if you didn't get your question answered, you'll get a chance. So our last speaker is AJ Steers. See, I had a whole little bio thing.
Test.
So he is an experienced architect, data engineer, software developer, and data ops guru. He's designed end-to-end solutions at Amazon and created a vision for quantified self-data models. And he's going to speak to us about text as data from anywhere to anywhere. Welcome, AJ.
Thank you. Thanks. Let me get this up. Let's try again. Nope. Nope. All right, we'll get it as large as we can for this demo. It's close enough. Yeah. Am I?
This.
All right, well, welcome. As was mentioned in the intro, I'm first a data engineer who always did software, and now I'm a software engineer who builds data products. So really, a lot of what I'm going to talk about today, I built for the past and future me, who was maybe in the situation you guys are in today. And I want to draw a connection between what we have always treated as data and what we are now treating as data, and make an argument that we don't need two different sets of tools for the text data and traditional data. And it would be really nice if we brought these silos together or broke down these silos. So I like this pseudo Spider-Man quote. We have so much data available to us, and we'll talk about some of the types of data that we can get access to now. And it's really about opportunity cost. How much time do you have to go get data from that 5th, 6th, 7th data set? that you think could be valuable. So unstructured data is everywhere, and unlike 10 years ago, Google Documents are valuable data. PDFs are valuable data. Ebooks are valuable data. The transcripts of the YouTube video that this will maybe become, or that something else, that is also valuable data. We'll talk about that. We'll talk about PyAirbyte, what it is and why. I'll do some demos, and we'll talk about Airbyte versus PyAirbyte and what is happening as we build out our product. So far, Airbyte has focused primarily on peace of mind, flexibility of deployment, robust connector library, get data from anywhere to anywhere. If you used Airbyte before, you're familiar with kind of that mission. And what we've done in the past 6 months is we've expanded beyond traditional tabular data sources to also cover unstructured data sources. And we've gone beyond SQL and file type destinations to also include vector store destinations. So some of the things that we support are on the screen. There's about 300 of them, so I'm not going to try to list them. But yeah, unstructured data is everywhere, and it's up to us to figure out how to harness it and how to make good use of it. So I mentioned some of these already. You might think of unstructured data sources as documents. We also have call summaries from your salespeople. We have now transcribed calls from Zoom. Everything is recording and analyzing, and it's creating rich data. And I can't remember what I had a meeting about yesterday. I could have that information if I wanted to with this data. Also, news articles are easily scannable, indexable, et cetera. There's just a very rich wealth of data, and these things live in a variety of traditional and non-traditional data stores. So really what I want to segue into is that we really have multiple communities here in this room, I think. Some people are coming from the AI side, some people are coming from traditional machine learning, some people are coming as data engineers or BI professionals. And if you are self-identifying as an engineer, you want something you can code for and control. If you're coming from an analyst side or maybe a manager of people who are less technical, you might want a UI. And so traditionally, those have just led you on completely different paths. And we're trying to break down those barriers by bringing Airbyte to anybody who can read and write Python, or anybody who can copy and paste a few lines of code. I'll show you some of that code in a second. So really, Airbyte can run anywhere, reduce time to value, fast prototyping, flexible, no deploy, and then test. It's just test, iterate, test, iterate, test, iterate. So here's the code. 3 steps. We'll go through it real quick. So create a source by calling get source. Hopefully y'all can read this. It's a little fuzzy. In this example, I'm using source GitHub. It's one of my favorite examples because it's a combination of tabular and unstructured data. I'm also in it every single day, so I'm always trying to wrangle my GitHub data. So step 2 is set config. Every source you want to get access to will need some kind of configuration, either an endpoint or credentials. We make this as simple as possible to set up. And then lastly, read the data. Depending on your source, you might have like 3 folders or 50 streams or 400 tables. And what you select, what you actually want access to, is the same. It is just your choice of what you want to select from these sources. So I've given an example here from GitHub. I want issues, pull requests, and stargazers. And then I have 3 different code samples. Again, I apologize if it's blurry, but the first example says read results, issues, 2 pandas. Second one says 2 SQL table, and third one says 2 documents. Depending on what you want to do with that data, the same interface will get you there. So what if 3 steps is too many steps? Some of you are maybe wishing there could be fewer steps. So let's do the 1-step version. This is the speedrun version of the same code. We get a source, but instead of storing the source object, we just immediately configure it, set what streams we want, call read, and we're done. So if you want to get data from any source that PyAirbyte supports, which is about 250 connectors right now, you can use a code snippet like this to do that. We're going to welcome PyAirbyte into the Airbyte family. Again, as I mentioned before, OSS Enterprise Cloud are really about ease of use, peace of mind, redundancy, scalability, all those things. But sometimes you just want a library. And so PyAirByte is that library. It can run anywhere. We just announced 2.5 weeks ago. We've had a really great reception, and we're looking for more and more feedback and testers. We are in public beta phase, which means not everything works, but we're taking feedback. As you can imagine, there's a lot of edge cases with that many data sources and that many configuration options, that many Python runtimes. Yeah, so back to the silos. Whether you're from Gen AI, machine learning, data warehouse analytics, or data engineering, this is a tool everybody can use. And we're working on also a migration path so that engineers who build this out in Python have a clear deployment path to the cloud, so that your manager doesn't have to worry about you babysitting that script. You can, if you want to deploy it to Kubernetes or deploy it to cloud. So let's switch to demos, assuming the screen share cooperates. It's all right. So first, before the demo, just want to show you, here's a list of connectors. You can come here to the Airbyte site and just scroll through what sources we support. I just have it on the files here. I also have sales, etc. So you can browse that as you wish. Here's the quick demo of the hosted version. Let me bump up the font size. So I just quickly have a Google Drive source. And you can configure it by copy and pasting link to the folder that you want. Similarly, I can go to destinations and I can type in Milvus and I can go to my Milvus destination. I can configure, one thing I didn't mention, but on our vector store destinations, we received feedback that people really want to be able to chunk inline and do embeddings inline with no code. So that's built into all of our vector store destinations. You can configure chunking right here, and you can choose embeddings. This is for testing. You can just pick a fake embedding, so you get random vectors, but more likely you're going to OpenAI, Cohere, Azure OpenAI, or any OpenAI compatible endpoint. If you choose this, then you just provide the base URL and you're off the races. Again, no code here if you don't want to write code. All right, with that, I'll just show that the indexing here is matching. This is not exactly a Zilliz demo, but it's close as we're going to get in this short amount of time. Here's my cluster. I copied pasted this endpoint into my config, and that's where I got it. Okay, so that concludes the UI part of the demo. Now let's get to the code. So let's find out where I am. So we have here, I'm scrolling up. I did pre-run this just to make sure that I didn't have bugs, but I'll rerun it now. Let's hide this tab and let's hide that. So here I have the same code generating 4 different sources. These are all Python sources, part of the connector library, and I'm just going to run the same command 4 times with 4 different string inputs. I've suppressed the connector config because y'all don't need all that detail, but just to show you it's the same code. This installs the Python from pip. Each of these have their own Python library. And then for each one, I can see what the available streams are for this. So for GitHub, here's a list of streams. Let me bump up the font size. And so you can see there are a lot of streams here. There's a lot of data people have already built in. One thing I forgot to mention earlier, all of our, not all of them, but all of them that make sense have incremental read built in. So the next time I pull my GitHub issues, I'm not going to have to go through the 60,000. It's just going to get the ones that have come in since the last time I synced. All right, so we can run that same code here for see what's available in HubSpot. You kind of get the idea here. In Google Drive, I have 2 folders configured, test and test unstructured. For GitHub data, so let me pause here. That's how I can see what streams are here. Now we're actually going to read the data. I'll run each 3 of these in sequence so you can see them running if they can not move on me. I'll just use my point and click. Yeah, so you can see as they're reading, it's getting the data. Because I just ran this to make sure it went, all of these are actually running incrementally. You can see this finished in 3 seconds and there's nothing new in the last 5 minutes. So sorry for not as realistic of a demo, but you get the idea. And then one last part of the demo, I want to show, great. So we've read from 4 different data sources with about the same amount of code, less than 20 lines, I think, of code for all 4 of them together. Now, what if we want to generate documents from that tabular data? So this is an example where instead of reading to a cache, which was we just did, we can read directly from the source in a function we call get documents. Here's the stream name issues. I want property, title is the title property, content properties is the body. So render these as documents for me. Now these we duck typed to be compatible with LangChain, and we just did a demo with LangChain. Time flies. Last week, I think it was, as we launched our LangChain Airbyte connector. So if you're a LangChain user, you can go to the LangChain Airbyte installation, but you can also go straight from here. These are compatible with the LangChain document format. And here we've just printed them in rich. So you can see here are my GitHub issues rendered as documents. The title's up here, and here you can see the rendering. So that ends the demo, and I'll get right back to my slides. A couple more slides if I'm good on time, and then we'll wrap. Cool. So, where did I lost my, here we go. Oh, now it goes full screen. Of course, now it does. Okay, so Airbyte or PyAirbyte, choose your own adventure. Yeah, I think you kind of see where we're going here. If you want the zero code load to vector stores, or if you just want to point and click your way through, this is the way to go. Airbyte Cloud, OSS, Enterprise, depending on what level of support you want. If you want all the control with very little code, but you still want that code and commit the code and have it locally and have control and run it where you want to run it, including, as you've just seen, a Colab notebook that I'm not even paying for. You can run through here. So we run on Colab, Jupyter Notebooks, VS Code. We are looking for people to test in other environments, such as Snowflake, such as Dagster and Airflow. So if you're interested in that, let us know. But yeah, anywhere Python runs, in theory, if it can support virtual environments, it can support this. And then a couple things that are up next for us. Right now, PyAirbyte does not support full destinations, so it means you don't have vector store support in as destinations, but you can easily pass them along to LangChain, like I said, and still get them into vector stores that way. But we'll be adding that next quarter. And then working on interop with Cloud, OSS, and Enterprise, so you can use the same tool also to orchestrate cloud jobs if you'd like from Python. Yeah, so some information here if you'd like to get started. Best way is find us on Slack. In our PyAirbyte channel. And I really, really hope you guys, if you're interested in this, if you think this will be valuable, give us feedback, please. It makes the product better, and we really appreciate it. You'll see me in GitHub every day responding to issues and feedback. Cool. Thank you. Thanks.
Thank you, AJ. Got some excited Airbyte users here. Got a question here.
Hi, thank you for the great demo. I know you mentioned the cloud version. Is there also an on-prem version for customers who are sensitive about their data?
I didn't hear the very last part, but let me, what was that?
Yeah, I know you mentioned there was a cloud version. Wondering if there's also a version that I could install on-prem for customers that are sensitive about data?
Yeah, absolutely. So we have two options. If you just want to run the OSS version, it runs in Kubernetes. You can spin it up yourself anywhere Kubernetes runs. If you want to have added support, we also have an enterprise offering that can run in your cloud or on your prem.
And we get the UI access and everything else?
Yeah, so that specifically is the hosted option. PyAirbyte we don't have a support model for it. We're still in beta, but if that's interesting to you, let us know. But yeah, what I mentioned was for the UI part. Yeah.
Got it. Thank you.
Yeah, thanks.
With PyAirbyte, am I able to bring in just local documents, PDFs, PowerPoint files, etc.?
Yeah, yes, that's the short answer. In the PyAirbyte model, everything is a source. So you would use one of many sources. There's a file source. There's a sheet source. I think there might be an Excel or CSV source as well. Yeah.
Is there a need to use another streaming technology under this, or is this giving all the guarantees that it will be delivered once and only once and all of that?
Yeah, great question. No, there's no need for another streaming service. The sources, either the platform or PyAirbyte will keep track of the state of since the last time you ran it, okay, you got to this marker, this cursor value, and then next time you run it, we'll get the next. So, and then in terms of redundancy, would recommend cloud or enterprise for the best kind of guarantees of service, if that's kind of where you're going. Yeah.
Okay. Oh, I see a question up there. Chris, in front row.
You mentioned about the newspaper. Suppose in the newspaper, we
Yeah.
have to scan the data. And what about the inconsistency in the data later on? When you scan the data, it becomes a little unstructured. Like it's unstructured data, but it becomes
So
reliable.
you
Because
said,
I have worked on a product before where
Uh-huh.
you have to scan the data. And when I deal with that data, that data is very messy.
Yeah. So you're talking about like OCR and image recognition. Yeah, we're not trying to solve for that, except all of our unstructured sources do process PDFs and other image formats. We use the open source unstructured library from unstructured.io under the covers. And there are different levels of processing you can use with that library. You can bump it up to like like more GPU, and maybe you'll get a better render. But yeah, that's it's a hard problem. We're not trying to solve that, but we are trying to use open source under the hood to cover that. I will say, once it gets passed down to your destination, it's all been converted to Markdown. So any fields we got from the image or the text, either like a header hint or a list hint, we convert it to the Markdown so that once you're processing the data, it looks and feels like something a human and a machine could parse.
So you have an existing library of connectors already. What does the process look like for building your own connector?
What a great question. So thank you for asking that. We're really, really proud of our no-code connector builder. So if you're building any kind of source that hits a web API, you can use basically point and click interface, copy paste like the endpoints, type in the information of like what data is expected. It'll retrieve it, guess the JSON schema. You can fix it if you want. So there's a really good experience for building that. And you can just go to our website and find the no code connector builder. Yeah.
Yeah, just a follow-up question. So what happens when somebody builds that? Is there a process to promote it to production? And
yeah, we have a process where that can get incorporated into our catalog. We take contributions, and that's why we have so many sources. I mean, we could not do that on our own. It's through the support of the community, and that connector you want, somebody else probably wants it too. Yeah.
Thank you.
Cool.
Oh, I guess one more question, and then we'll have one Twitch, and then that should be it.
Cool.
I see you are able to ingest both structured and unstructured data. Are you able to also retrieve and respond back to prompts with the combination of both?
So we are not trying to be the LLM layer or to be any part of like the lane chain process. We can feed both structured and unstructured data into the same or to adjacent vector stores. And then from there, you'd have, you'd be able to do that. Does that answer your question, or is that a different one?
Yeah, so what I'm asking is when you retrieve data, would it be also referring to both vector stores at the same time and augment it a single response? As an example, I'm asking, tell me the top 2 customers that are paying my highest revenue, but also tell me their background.
Yeah, I don't think that Airbyte would help you with that part of it, but if you retrieve each chunk and send it to the right part of your flow, then absolutely you could have like a lang chain process, for instance, that does one. If unsatisfactory result, go to the next, and all of your raw data would in that case be provided by Airbyte or PyAirbyte, just not that Airbyte's not doing that process. And I guess that's a really important thing to call out. PyAirbyte's not trying to get in the way of any other part of the process. That's why we have like the pandas handoff, the SQL handoff, the documents handoff. So we're really trying to get it to all the other tools. Our bread and butter is getting the data from one place to another, and we don't want to be in the way of that next step that you might have, that business logic you might have downstream. Yeah.
Christy, we have one more over here.
Hey, so I understand that, I'm here.
Hi.
So I understand that your product is good for extract and load.
Yeah.
How much of transform is suitable to do here? Like if
Such a great question. Yeah.
Load a CSV,
yeah.
Can I do spatial queries? Can I do
Yeah.
reference to external data sources in the process of transform?
Yeah, that's awesome. So one of the reasons we built PyAirbyte is that when we were building before just unstructured sources and vector store destinations, a lot of our users were telling us they wanted to do something in between that process. And there wasn't a good way to do it because there's no place to put the custom code if you're just in the UI, nor should there be. I don't think we want like spaghetti Python code in that place. So the transformations we do, the ones we do already, and are the ones I mentioned. Chunking we do, embeddings lookups with any of those providers, and we also parse the unstructured source into a usable markdown format, separated into the kind of buckets of content or structure, content or text versus metadata. So we handle that for you and we just hand it downstream as a document that can be used or as a tabular data set that can be used, but we don't want to be in the middle. And I think that's why PyAirbyte is resonating with people a lot, because you can just immediately take it from there. But that's not something we're not trying to do complex transformations. Yeah.
Hi, thanks for the talk.
Thanks.
So one question that I had was if I wanted to like inject or have some sort of layer for like a data contract or an API contract, where would that place be? And is it even in this sort of stack?
Do you mean like a upstream data contract?
Yeah.
Can you give me an example?
So let's say that I had a connector that I was using from Airbyte, and let's say that the schema that was coming in was not necessarily something that I wanted, or I wanted to enforce something very specific, and I didn't want to take data in otherwise, and I didn't want to use those resources.
Got it.
Yeah.
So Airbyte, the Airbyte protocol is built on JSON schema as a validation foundation. So the way that source authors define what shape or what contract the data should, like the way I got the catalog information and the list of streams was through that metadata. So that's how it is provided. Yeah.
All right, I'm going to ask one more last fun question from Twitch. Are you going to stick around?
Yeah, I'll be around.
So if you didn't get your question answered, AJ is going to stick around.
Yeah, come talk.
Okay, so let me ask this last Twitch question. You mentioned quantified self.
Yeah.
Can you say more how that relates to Airbyte?
Oh, yeah.
Or your thoughts in general about quantified self?
Absolutely, I love that. I'm a big data nerd, as you might have guessed. I did in my career work at a startup called Airavail that basically partnered blood work and DNA tests with a coach to help humans improve their health through metrics, through BI. And that came with an obligatory Fitbit and taking photos of your stuff. And how that relates to Airbyte, only in such that we have a Strava connector, and you can build I think there already is a Spotify connector, and whatever you can think of that you want to get data from your quantified self, you can build that connector, you can hopefully find that connector, and I think that's really fun stuff. So yeah, cool question. Yeah.
All right, so let's thank our speaker again.
Thank you.